troops. Well, I've got my box of goodies, the radio and something else. I got my certificate from the RSGB back a few days ago, so I'm now registered with Ofcom and have a call sign. So now we can think about getting it on the air, but it's not quite as simple as unboxing and plugging everything in. I've started the unboxing, but then the battery went flat, so we'll redo the unboxing. This isn't about an unboxing really, it's about getting on the air, but to get on the air you've got to see what we're doing. So the radio I've got here, just to keep things simple in the early stages, is an Anytone AT-778UV. It's a dual band VHF and UHF radio. It'll put out a maximum of 25 watts. I am not allowed to use 25 watts, so I'll use it on the lowest setting. It's very small, it's designed to be mobile, but I can use it in the shack and I can use it with a battery and a portable antenna. I should be able to put that in a backpack, no problem at all. So that's the radio. When I bought the radio, I also ordered a device called SWR meter, and that's because I haven't bought an antenna for it. I'm going to make one because I've got to save where I can. The radio, by the way, cost me a 5p short of £100. So that's how much the radio cost, and I got that from Waters and Stanton. I got the SWR meter from Waters and Stanton, and it is the Charman AV-1000. This cost me 90 quid, and the reason I got such an expensive SWR meter was because this covers all the bands from HF to 23 centimeters. So I shouldn't need to buy another power or SWR meter. So that's the equipment I've purchased, but that's not enough to get me on the air. Oh, before I ordered these, I actually ordered another piece of equipment as well. And that's in this box here. And this is a Nano Vector Network Analyzer. When you're checking for resonance of your antenna, with an SWR meter you need to actually plug it into the transceiver and put some power into the antenna. With this device I don't need to plug the transceiver in at all. I can check the resonance of the antenna with just this. I'm not going to go through this, plenty of people have gone through this online. I got the slightly more expensive version because it has a bigger screen, but there's one thing in here that I noticed and I suspected I would not have, which I need, and that's in the back of the radio. There's a SO239 socket, and so a PL259 plug goes into it. So I'm going to need something that will change this PL259 plug into the SMA socket for the VNA, if any of that makes sense. Anyway, all I'm saying is I've got to get an adapter to adapt the radio to the VNA, but I'll do that. So antennas then. So well, I need more than an antenna. I also need a power supply. I do have a power supply for a CB radio. It only puts out 4 amps, and I'm not sure it should be enough to power this up on low power. So it should be, but if not, I can connect a 12 volt battery in parallel, and when the voltage drops a bit, the battery will supply that extra voltage. We'll see. But I need a mast and an antenna. Right, so I've done my research, and I was considering either a quarter wave ground plane antenna or the half wave dipole, and I'm going with the half wave dipole. So we're just thinking for the moment about VHF. We're not going to get too complicated. It's one thing at a time. So I want a centre frequency of about 145 megahertz. So there are two calculations, one to give you an answer in metric and another to give you an answer in feet and decimal inches. So we're going with the metric then, and it's 143 divided by the frequency in megahertz, and that gives you a half wave total length of approximately 98.5 centimeters. So you're feeding that at the center point, so your coax splits that half wavelength into two quarter wavelengths. So each element of the dipole then will be about 49.25 centimeters. And if you wanted that in imperial, that would be about 1 foot 7.5 inches off the top of my head. Approximately 1 foot 7.5 inches. But I'm going to stick with metric. So all I've got to do then is get two elements vertical, connected to some coax, connected to the radio through a SWR meter to start off with. So in my research there were some things which were going to affect this measurement here. One of them is the height above the ground that your antenna is. The next is the diameter of the wire that you use, and the third possibly is whether or not you've got a balun, because some people you say you need one for a dipole and some people say you don't. So if you don't need one, we probably won't have one, but I might just use some coils of coax around there, about 7 or 8 coils depending what I feel like, and that is aimed just at reducing any flow of current back into the radio from the outer shield, because apparently at radio frequencies the electrons behave very peculiarly. So in your coax, so say that as your center core of your coax, and there's your braid of the coax, so you get your signal essentially flowing up the center of the coax and flowing down the inside of the braid, but then you can get a separate current on the outside of the braid. So you've effectively got 3 conductors when you think you've only got 2. So apparently this coiling of the coax just affects any current on the outside of the coax flowing back down and causing interference. So we might think about that. So that's the mast we're going with then, a simple half wave dipole, 2 quarter wavelengths. So the total length then is got to be approximately 98.5 centimetres. But we've also got to allow for this gap in where you join the centre conductor to one element and the coax to the other. We've also got to allow for that. But these are only approximate measurements because of factors which will slightly change things. So best we make them, cut them slightly longer, and then we'll know that we need to cut bits off to fine tune the resonance rather than add bits on. Right, so what are we going to make the antenna out of then? Well, right then, you may hear some noise, background noise, which is the lashing rain on the shed roof because we're in the middle of Storm Babbitt. But I've got my idea for mounting the dipole, 2 metre dipole, on top of my scaffold pole. Now I've got this large waste pipe which fits over the scaffold pole, fits nicely over the scaffold pole. So if I let it drop down over the pole for 18 inches say, drill 2 pegs in so it stops at those 2 pegs, then sits on top of the pole like that. I've drilled 2 holes in it, or 1 hole all the way through, to fit a second waste pipe through like that. And then my antenna, my dipole, which consists of these small bore copper tubes, I've currently got them cut to approximately 1/2 metre each, which will be a little bit on the long side, but best cut them a bit on the long side rather than have to add bits to them. So I'm going to mount those on this piece of wood I've got here with some sort of tie wrap, plastic tie wrap, bit of gaffer tape maybe. I'm going to mount them like that, and this will then be mounted into there like that, and that will give me my dipole sticking out from the mast. Now I'm a little bit concerned about, I decided to solder the coaxial cable onto these elements. I may have a little bit of difficulty doing that because copper is a great conductor of heat, but we'll see. I'm using some old RG58, which is not ideal. It's you can get much less lossy cable than RG58, but the run's quite small, straight out the window and straight up from the radio to the dipole, so it won't be more than 4 or 5 metres. I've got acetone to clean any grease off these rods. I've got resin cord solder, and I've got some extra flux because I think I'll have some difficulty with this copper. I will be able to generate a little bit extra heat. Don't forget to slip the other part of your PL359 plug onto the coax. I do believe I've done that, unless it's fallen off. Let's just have a check. Oh yes, it's there, as long as I put it the right way around, of course. But I think I have. A bit of flux on there. This is resin cord solder. Now we call it soldering. Soldering. You Americans have a slightly different term for it, but this is resin cord solder, and I've put a little bit of flux on it. The resin, of course, is the flux, and you can make your own flux from the resin of the pine trees. And we're going to do that presently, but right, so we'll just have a quick continuity test. There should be no continuity between the two elements of the dipole. I do have a meter here. And it's got a resistance setting on it where I can just test the continuity, and it should make a tone. I don't know whether you can hear, that's quite high pitched. I'm going deaf, so I don't hear it too well. But there shouldn't be any continuity between the two elements. There is no continuity between the two elements. Right, so one should have continuity with one of the elements, not that one, or that one. And the middle pin, which I'm hoping we haven't heated up too much, and now it's slightly offset. Oh dear me. Right, nothing there, so that's looking good. I'm a bit worried I've applied too much heat, and that centre pin is now a bit cockeyed. Right, this is actually a CB rig, this one. I'm just testing that the plug goes in. Yeah, it seems to go in alright. Seems to go in alright. So now, now I've put a plug on the end, I can now check what the resonance of this antenna is, and I am expecting to have to cut some off each element to bring the resonance to the frequency I want, which is higher than the frequency it should be currently resonant at. The shorter the wavelength, the higher the frequency. And this is how you determine with an SWR meter how to tune your CB antenna. Right, but we're not going to use an SWR meter, because that means connecting it to the rig and actually transmitting. What we're going to do is use a device which I've just purchased. Well, actually I ordered it before my VHF radio, but it's not long since come, and that is a Vector Network Analyzer. But before I do that, I'll just have to swat up on how to calibrate and use it. It does a lot of things. We just want it to check the SWR of this antenna to see what what we need to do to get it resonant on the frequency we want it, which is approximately 145 megahertz. Right, enough waffle, let's get on with it. I'm going to check the resonance of the antenna where it is, which won't be exactly the same as its final location, but it'll give us a good indicator. And besides that, it's pouring down outside and the antenna will not be waterproof in its current state. Right then, so I've basically built the antenna, but we don't know what frequency it's resonant at. And I could use an SWR meter, a VSWR meter, but I bought myself a Vector Network Analyzer, which will tell me exactly what frequency the antenna is resonant on, providing I carry out the instructions correctly. I'm not going to go through how to use this because there's plenty of videos already on it, but needless to say, it has to be calibrated first for the frequency range that you wish to scan, and I have calibrated it to scan between 100 and 200 megahertz. Now I think the resonant frequency is going to be a bit low, so we'll see. I've got this adapter to plug onto the coax plug, so I've got this socket that fits on there nicely and then goes into the SMA connector on the network analyzer. As I say, I've already calibrated and set the range on this, so if I switch it on, it boots up. It's not coming exactly where I want it to, so let's go into recall. Okay, so you can see a trace there on the graph, and along the bottom is the frequency from 100 megahertz to 200 megahertz, and on the vertical side it's SWR with each mark being 1. So you can see the marker right at the far left, and it's reading 3.31 to 1 at 100 megahertz. But if you look further along, there's that dip which goes down nearly to 0. So we'll just see what frequency that is at. And I can joggle this cursor along. Just joggle the cursor along. So this antenna is currently resonant at approximately 132 megahertz, where we've got an SWR of 1 to 1. So I need to cut a little bit off it. So I'm going to cut 1/8 of an inch off it. But the next time I test it, I'm not going to test it here in the shed, where there's lots of cables and bits of metal strewn around. I shall put it in its working location, because everything makes a difference. But at the moment it's raining. But you can see the elements on top. When I cut it to 49 megahertz, you've got this gap to take into account as well. So the next test then will be in situ when it stops raining, after I've cut 1/8 of an inch off. So if you're going to muck about with antennas, I mean, for the price of these things, Vector Network Analyzer, for the price of a Vector Network Analyzer, and it does a lot more than SWR, but I haven't figured the rest of it out. Right then, so this is the setup. The antenna is up. In its final position, it actually wants a little bit more shaving off it. but it's working splendidly. I'm hearing the repeater in crook. I'm also monitoring the 2 meter calling channel, 145.5 megahertz. Anyway, any operating will be a video for another day, as this video has now gone on quite long enough. That's the repeater I'm listening to on the secondary channel there. It's got a, well, I'm not going to go through what the radio is capable of, a little bit more than I fully understand at this moment in time. So we'll end the video here then, and antenna tuning is not so difficult when you have a vector network analyzer, that's for sure.